When looking for the domain of a function, we have to recall that the domain is referring to the set of all x values for which a function is defined. So we're looking for all the x values of this function. In our example here, we can see that this graph, this function starts right here. Now we need to know what is the x value of this function. So we go down and we see that the x value is 4. So this function starts at the x value 4. Now where does it end? This arrow indicates that it keeps going forever, so it doesn't end. Therefore, we can define the domain as we're looking at all the numbers, all the x values, greater than or equal to 4. Greater than because it's pointing to the right. We want all the numbers greater than this x value, which is 4. Another way to write this, we can say that it starts at 4 and it doesn't end, so it's going to approach infinity. Keeps going forever, goes all the way to infinity. In our next example, we're once again looking for the domain of the function. So all the x values of this function. Once again, where does it start? We need a starting point. It starts right here. What is the x value of this starting point? We see that it is 2. Now it's pointing to the left and it has an arrow. It's not going to finish. So we say it's going to approach negative infinity. Therefore, once again, we can define the domain as all the x values, not greater than, because there's nothing over here on this side of 2, right? There's nothing greater than 2. We want all the numbers, all the x values, less than 2. So once again, when the square root function, when the graph of the square root function is pointing to the left, we're going to want all the x values. The domain is going to be defined as all the x values less than or equal to the starting x value. In this case, 2 as in our second example. And when it's pointing to the right, we're going to define the domain as all the x values greater than or equal to that starting x value.